Port on this computer. Hide floating controls. All right, so let me see what this dude first initially does right now. So right now, does it just load the next scene? Okay, loads the scene, but if you remember from the end of last class, we set it up so it's on trigger exit. That way we can kind of see it, it's rolled off the screen, so to speak. Look, he actually starts falling. You see that from the side? Yep. So in any case, if we go to the right here, I want it to start rolling in from the left. All right, so what are some ways we can accomplish this? Well, on one hand, if we go to the right, we want to figure out what's that position there on the left that they would roll in from, right? Because really we have four possible positions, four possible vector threes, right? They can be starting here, starting here, starting here, starting here. So let's get it placed correctly first, okay? Now, a couple different things we can do here. So one thing I'm going to do is I'm going to go ahead and duplicate this guy. And then I'm going to move him to the left here. That kind of marks a position I might want the guy to start at. And let's go ahead and have it maybe overlap a little bit, just to make sure he doesn't fall off the edge of the edge of the earth. We'll just use this as an experiment. All right. So we're going to call this guy West. Call that West Start. All right. And then what we're going to do is we're going to go ahead and just turn off the mesh renderer so we don't see it. Okay, effectively, this is an empty game object. We can also we can remove the box collider. We can just make it an empty game object so that technically all it is a transform. Right? All right, and that gives us a position. All right, in fact, for purposes of performance, why don't I go ahead and remove the box collider? I'll just remove the mesh renderer and I'll remove this mesh filter. So now all that guy literally is a transform, empty game object, okay? I just duplicated that box to help me get it positioned correctly, by duplicating it and then just moving it to the left, okay? So now we have this position. So what I want to do is I want to, for the sake of argument right now, let's go ahead and get our, regardless of what exit this guy goes through, let's have it just start here. That's kind of our initial starting point. Make sure we get it positioned in the right place. And then we'll figure out, well, how do I then nudge it to get going in the right, get going towards the center. And then we can do the logic of making sure when it exits one door, where do I go from here? Make sense? Okay. So with that in mind, who is governing this right now? Do I already have my Visual Studio? I do not. So we're going to go ahead and we're just going to do this with the player controller right now. I think that's where I have the on trigger exit, right? Big money, big money. All right, so where's my on trigger exit? On trigger exit. Oh, so we even used the singleton. Had I done this last class? I think okay. So we used the singleton to remember where we were coming from. So this is going to be helpful, helpful for us next time. All right. So what we're going to go ahead and do is we will on trigger exit, we go ahead and we just let our singleton know about the exit that we came from so that we can make some decisions someplace else about where we should position ourselves. All right. So for load scene, and I think I started off as like a question mark or something like that. All right. So if it's a question mark, we want to go ahead and just have it start in the center, right? Kind of that's how our game begins. If it's not a question mark, we want to have it start at another location based on what that value is. Right now, that location we know about is that west entrance. So let's just get it working on the west. We'll just assume, regardless of what exit you go through, you're starting on the west. All right. So we want to say if it's not equal to a question mark, we want to do some stuff. So inside the player controller, when this guy first starts, now you can decide at which point, like when do you want to do some different things here. You could actually make an argument that maybe you want to put scripts on the camera. And when that starts, because that should be before the user can actually see anything. But timing wise, this should work out okay. All right. So what I'm going to do here is at the very beginning, I'm going to ask the question if master data oh, what was I doing here? Oh, that was just showing you the difference between singletons and that kind of stuff. All right. So if master data dot where did I come from dot equals a question mark. If that is not true, all right. So if it's not true that master data, where did it come from, is a question mark, then we want to put this guy somewhere. We want to change the transform of our player. Okay, of this guy, because this guy's game object is attached, well, is the player, because that's what the script is attached to. Okay, but we're only going to do this and start if we are not looking at a question mark for where do we come from, which we have only when we first do it. All right, but right now we're not going to ask any additional questions. Let's just assume we're going to position it at that new location. Now, what I'm going to do is I'm going to give myself some public variables here. So I'm going to say public game object. We'll call this guy West Start for right now, because that's all I have, right? We'll go back into Unity here, and we'll click on our player. And here, this guy's expecting a West Start. So I'll go ahead and drag West Start over there. So now we have the game object associated with West Start, which is effectively an empty, invisible game object whose transform is holding on to a very nice location for me. Okay. This isn't the only way to do it. It just makes it relatively flexible rather than me hard coding a vector3 inside my code. Now, if I decide I want it to start in a different place, I just have to drag West Start around a little bit. For instance, there's a risk here, depending on my position, that I might not have moved it over to the right far enough, and we might put the player there and it just drops out of the sky. All right. But I think I have him on the edge of the table just enough. We also need to make sure we position the player high enough that we don't just embed him in the middle of it. Okay. But let's get him in the right place first, and then we can massage the numbers to get him wherever. All right, so now we have access to this game object called West Start inside of my code. All right, so if we're not looking at a question mark, right now we're going to assume we want to place that player not at the center, but we want to place it at West Start. So we're going to say this dot game object dot transform dot position. And we're going to be talking about the difference between position and local position at some point today. So we're going to set this guy's position equal to this dot West Start dot transform dot position. All right. So we're just going to arbitrarily change our player's position equal to West exit's position. Okay. So let's start with that guy and see how this behaves for us. All right, so we'll go north. All right. So now he's over there. All right. And what I think actually happened, I think he did get placed kind of in the middle of it and then kind of nudged up. If you saw kind of how it went down, oh, see, keeps getting reset there because he's exiting the trigger. Okay, so we might need some logic there too. All right. Well, now let's get them positioned correctly now. All right. So now we can ask the question based on where we want to put them. So let me stop the game here. Here's my west start. We'll make some copies of that guy. So we'll call this guy east start. Rename. There it is. So there's east start. And let me just double click on my player here. Then we'll click on east start and location. And we'll just drag that guy over here. We'll call that perfect. All right. Then we have our, call this guy north start. And we'll drag that guy. I'll just say right there. Perfect. And then we'll call this guy south start. And drag. Oh, I'm good. Drag that guy. Oh. Right there. All right. Again, we'll call that perfect, and we can nudge it a little bit if we need to. Okay. So now I want to go ahead and give myself access to these other 3 start positions inside my code. So I'm going to go ahead and add east start, north start, and south start to my code there. And then let's go drag those guys in. So there's my player script here. So I need my east start, which is this guy. Now, one thing that you may have seen in some of the examples, if you're looking at videos and things like that, sometimes what people will do is they'll move this hierarchy over here near the inspector, or move the inspector near the hierarchy. So dragging things between it like this is easier. Okay. But I like to play this like a video game, and it's like, kind of hard to land. You know what I mean? So there's my north start, and then there's my south start. All right. But you do whatever makes sense for you. All right. So now let's go back and let's ask some questions. All right. So we know if we're inside of this if statement, we are not looking at a question mark. We're looking at something else. What are we looking at? Something like a north, a south, an east, or a west, right? So we'll ask the question, if master data dot where did I come from dot equals north. Then what do I want to do? I want to set myself at the south exit. Else if I came from the south, I want to set myself at the north. Else if I came from the west, I want to set myself at the east. Else if I came from the east, I want to set myself at the west. Okie dokie. All right, let's make sure all that logic's now working. So again, goes right back to week 1 of CSC200. Remembering stuff, asking questions, and then repetition. All right, so we're just asking a bunch of random questions there. Not rocket science, right? So we go to north, it should pop in from the south. I got to run it again here because we currently have to find a way for us to deal with the trigger guy. So there's from the east, he shows up at the west. There's from the west, he shows up at the east. I think it's because he's coming into the middle of the box, the collision box, and then it's kind of like squishing him up. It's trying to do a collision response to that, a physics response, and what it's doing is it's shoving it outside of the geometry.
It's not on top of the yellow box.
I think in the end it ends up being on top of the yellow box, but I think he's coming in the middle of the yellow box. I think what we can do is we can put his position up at a half, a half a thing on the, what would that be, on the Y? Yeah. So if we put it a half unit up on the Y, I think then he'll be sitting on top of it. So, you know, we can play with that level of precision if we want. Test all of them. There's my south. He shows up at the north. All right. So he seems to be doing all the stuff he's supposed to be doing there. All right. Next thing we need to do is we can still test this ourselves by saying, you know, hey, right now I have code that says on trigger exit, set this guy back to where set this guy back to something else. Well, right now, my I want my on trigger exit to kind of disable for a second, right? Because I want this guy to be able to roll freely for a moment. All right. So what we're going to do here is we're going to create another Boolean variable up here. So we're going to say is exiting. Something like that. You can name it something better if you want. So very first time through, let me think about this. That is going to be problematic. So if we put it in here and I want to keep track of whether we're currently exiting or not, and I say this dot is exiting, and I set it equal to false, or let's say the first time through, I want it to be true, right? All right. And then down here, when on trigger exit, we want to say if we've run into something that is an exit and this dot is exiting. Well, I would probably say is exiting is true like this. You can say equal true if you want. But both of those things need to be true in order for us to say, okay, we're going to exit and reload the scene. All right. Only if we're currently exiting, which we are. Initially, we're going to keep track of whether we're exiting. We're going to set it off as true when we hit start. All right. But the problem with this is we're going to go ahead and run this. We're going to see that it has not solved our problem yet. It's going to work normally the first time through. All right. But now I still have the issue. Okay, where it's not allowing me to exit again. So with that in mind, what's the problem here?
It's triggering the exit function and it's constantly.
What's going on with this dude? When does that happen?
It starts with save.
Every single time I load this scene, I'm resetting his exit or is exiting to true, even if my intention was for it to get flipped to false when I actually exit it. So by me having this code inside of the scene here, or inside of this script, that gets loaded every single time we have the scene, it's getting reset each time. How do I move this knowledge outside of the script in such a way that it does not get reset each time? We can put it up in the singleton. So I can go into the singleton here. And I can create a public static bool is exiting. And I can start that guy off at true. All right. That'll be his default value is true. So now I'll come back into our player controller. We're going to get rid of this variable here. We won't reset it here because he's already starting at true the very first time, which is what we want, right? Inside of on trigger exit, we're going to say if we just bumped into an exit and we're currently exiting, then we want to do this other stuff. All right. Otherwise, now for right now, we happen to know that the only things we could be bumping into are things that are exits, but we want to kind of be explicit about this. And we're going to say else if this stuff is true and we are not currently exiting, then what do we want to do? We're going to go ahead and let it exit, but we're going to go ahead and turn off, or turn is exiting back to true. So the sorry, master data dot is exiting equal to true. Okay. Otherwise, after we set our singleton to the direction we were coming from, we're going to go ahead and set this guy to false. So when we are currently exiting, we'll make sure we mark the thing of the direction we're coming from, and we'll also say we're no longer exiting because now we're going to be entering from another location. And when we enter from another location and on trigger exit gets called, we will fail this if statement. Yes, we ran into an exit, but is exiting is not true. Instead, we'll run into this else if. Yes, it's an exit, but is exiting is false. What do? I don't do anything in terms of relocating it, but I go ahead and mark is exiting as true again so that the next time it exits a trigger, it'll do the relocation thingy. Make sense? So let's go back here. All right, so now it's positioned me, but now I can get out of there. Once he started rolling, I can't, there we go. Never hit the trigger. We can make the, make the collision boxes giant. And all right, so at this point, it's doing what we wanted to do in terms of allowing me to exit the is trigger exit. But I need to get pushed towards the center, ultimately stopping at the center. All right. So once we've positioned our guy, what can we do to get him rolling towards the center? Go ahead. Let's add a force to him. Okay, we're gonna shove him. All right. So we'll come back in here. So after we set his position, we're going to go ahead and we're going to say, we probably need to go ahead and give ourselves a rigid body. Actually, hold on. Do we have a rigid body for our player? Let's set that before we do this. That way we can shove it. Right now, I don't have that rigid body set. We'll go ahead and access the rigid body. Actually, let me just do all this stuff up above it. I'll take the print statement out. All right. So we give ourselves the rigid body because it's rigid bodies we apply force to, right? And then we'll keep in mind that currently we are not moving because the player has not set this thing in motion. We're going to have this guy automatically set in motion. Okay. So if we are coming from the north, we position ourselves at the south, we want to add a force. So we're going to say this dot RB dot add force. Now, when we add a force, we're going to give it the a vector 3 for the force, and then we're going to give it a we have multiple modes for this too, right? We'll just do add force here. So we're going to add the force. Now, the force that we're going to add is going to be a vector 3, and really it needs to be a direction, right? So if I'm coming from the south, I want to add a force up, right? All right. Now I can create these vector 3s by hand and say, okay, well, this is what the up force means. It's going to be pushing on the Z axis, right? But built into vector 3, we have a, now, you don't like this? I think you think it's going to go up in the air? It might. Yeah, let's find out. I don't think it will. I think they're based on two-dimensional locations. Who? It might be. Here, I'm just gonna, for right now, I'm gonna just throw a times a 50.0 F. Okay, we're gonna make sure we head to the north for our current test. All right, so we're going to add a force to the rigid body associated with the player in the up direction. Let's find out what vector 3 dot up means in this context. And then we're going to go at a speed of 50. See if that's a hard enough shove. And remember, this is only going to happen if we're rolling to the north here. Dun, dun, dun. Was it not hard enough, or did it literally go up in the air? Here, we'll know real quick. Okay. Here comes the punt. All right, there we go. All right, yep. So up means up. is for some reason that reminded me of this old comedy thing about this comedian, something like, this guy fell out of an airplane, hit the ground, bounced twice, and lived. It's like, do you know how hard you have to hit the ground to bounce one time? So I don't know why that popped in my head, but it did. So, all right. So we do not want him to go up. Let's see what other options I have here. Well, before I switch it out, what kind of animal is up here and why? What can you tell me about that up guy there? Go ahead.
Is it just coordinates?
I want to know what he is in terms of objects. Is he a constructor, a field, or a method? Okay, why isn't he a method? No parentheses. Not a method because no parentheses. All right. Is it static or non-static? You think it's static? Why is it static? No, hold on. I'm asking from a class perspective. Is it owned by the class? Is it a class field, or is it an instance field? Is it a static field, or is it a non-static field? It's a static field. How do you know? Vector 3 is the name of a class, seemingly. So we're calling this field with the name of a class. Doesn't seem to be throwing us error. So if we were to go and look at that in the documentation, we would expect to see this be a static field, right? All right. So let's see. Do I have any other options for? I have right. Well, I have right and left. Forward.
Yeah.
Forward. Dun, 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 dun. Okay, so we'll tell them to go forward. All right, so let's What this? Oh, it's dot forward is the. It told me it's obsolete, so I had to spell it out now. Except you got to spell it more better than that. Suck
Didn't even
less.
notice that.
All right. All right. So let's see if a speed of 50 is hard enough, and then we'll probably put that in a variable. All right. Oh yeah, a little bit on the weak side, but he's moseying. He's moseying. Okay. So here, I'm gonna go ahead and up here. I'm gonna go ahead. Oh, we have a movement speed of 40 up there. Oh, but that is compounding based on time delta, right? Right. So you know what? I don't even want to put it in a variable. Just so let's make it 100 here because this is only happening once. It's not happening every single time we hit update. So we kind of need to push it hard enough to roll into the scene because we only get one shove. Okay, so we'll get that guy going. We're getting closer, maybe 150. We don't have to sit there and mess with this forever, but 150 I think is going to feel like it's reasonably okay. Okay, so let's call that good. All right, so now that's what we're going to do if we're coming in from the north. If we're coming in from the south, what do we have, a backward? Got back. If we're coming in from the east, we want to go to the right. I mean, if we're coming in from the west, we're going to be rolling from the east, so we're going to go to the right. And similarly, we're going to go to the left here.
Yeah, that's a really strong force.
Really strong force down.
What is it?
Well, I mean, it's actually an interesting question in that presumably the gravity is going to keep it from going through, but there probably is a force that is strong enough, given the mass of an object, that would break through the box. Kind of like in real life, you know, if we had you laying on this table and I start pushing down on you, there is at some point a force where you rip through that table, right? So the same would be true at some point. I'm guessing that the physics engine probably starts breaking down in terms of realism at some level in there, but you know, it would try to let's say at least emulate it. All right, so now we should be able to drive around north, south, east, west. Time it. Oh.
Oh. You got it.
No, I'll just go to the. So now we're coming in from the. Oh, I had those backwards. I had those backwards, so this has to be to the left. This has to be to the right. All right, so we go left. We go right. Oh, got it.
Yes.
Do it. Make it.
Make it. Yeah.
All right. Oh, I know. I got to bounce earlier, right? Oh, actually, I was going the wrong direction. Oh, I did do that one the first time. All right, there we go. I pushed down. I waited till it exited and pushed down so I didn't have to reset it. Okay, so now we have them rolling in the right direction. All right, now the last thing we want to have happen is what? We want to, when they hit the center point, we want them to stop because that effectively resets the scene, right? So we need to keep track of where the center is, or one thing we could do is keep track of where the center is. So what I'm going to do here is I already had this position thing kind of in the center that I disabled. So I'm going to go ahead and put that guy back. This is just an empty game object. I'll go ahead and take some of the stuff I turned off. All right. Now I am going to leave the box collider on this guy. All right. And I'm going to tag this. Well, I'm going to go ahead and add a tag. So I'm going to add a tag here called center. So now that guy's going to get marked as center. Oh, I clicked on something else before. Yeah, thank you. This guy is going to get set as center. All right, but notice here, I am leaving that box controller on there. And I'm going to go ahead and drop the center controller off of this guy for now. That was something else that I was working on. All right, so this guy is effectively an empty game object that happens to have a box collider. Okay, so now he can respond to things associated with collisions. So when my player rolls up and enters that trigger, I can say, well, if I just entered center, what do? Stop. Right? So we got to look at how do we make the guy stop. So we'll go into on trigger enter. Then we'll ask the same question we asked before. We're going to say if other dot game object dot compare tag, and this guy is center. Leave it at that for now. So if I just entered something called center, that's tag center, what do I want to do? I need to make myself stop rolling. So we'll say this dot rigid body dot velocity is equal to 0.0 float. What does it want to be? Does it want to be a or is it a set velocity? That's a vector 3. So we're going to set this guy to vector 3.0. So that'll be his velocity. Why is it a vector 3? Because we're setting its velocity on the X, Y, and Z. In case it's falling and flying forward, it has two different kind of velocities at play here. But this only happens when we enter the collider. We stop it from moving. All right. Now, what we're going to actually see is we stop it from moving probably a little bit short of center, because it's going to happen just as soon as we enter the that collider. We could go ahead and just reposition them slightly. We can put that center thing on there and say, go ahead and move your position there, and we're just going to call you good. But let's just see him stop first. All right. So we got that. He keeps on rolling. All right, so there he stopped. Again, a little bit short of center. We're going to miss it. Oh, we missed it. All right. All right, so we probably want to go ahead and reposition him. You know what we can do? That's going to be good. So I'm going to go ahead and take center. And we made him a lot smaller. But
I had the this.rb dot last week for vector 3.0. So my thing like stops, but it reduced the will only reduce the speed. So I had to add angular velocity to get that back.
how hard are you pushing it initially? Possible it's traveling too fast. Because you're saying when you set its velocity to 0.
Yeah.
Oh, actually, you know what? Is it? I wonder how you're adding your force. Are you adding your force the same way, or are you adding it every single update? Because if you stop its velocity, but you're still pushing on it after its velocity, then it would keep rolling.
Oh, yep.
All right, so let's see if this guy positions a little bit better now. Oh, see, it just did the same thing. Now, hold on. Why is that? The reason that is my collision box is now too small. It wasn't enough to stop it
Oh,
physically.
okay, so it's not the code that's the problem.
Yeah, that's my feeling on this. Um, well, you probably could reduce the mass on player. Yeah, if we reduce the mass too much, then when we shove it, boom. Just, you were going to the north. And what did we do? We invented the perpetual motion machine. We've been trying to do this for years. All right. Oh. Well, we actually could. We can actually turn on his kinematic. So rather than set its velocity to 0, well, we can just double up. So we can set its velocity to 0, but we can also say this dot RB dot says the kinematic is kinematic to true. And I think this should stop it dead in its tracks because no longer does physics bounce on it or react to it. No, it didn't. Still got a. So the angular velocity. Well, why is angular velocity a thing?
I was just screwing around with it.
Yeah. I mean, I'm fine with the fact that it works, but I don't like
Oh, 'cause
Question,
yes.
why would adding the force to take it to the, what we labeled the origin, I want that one, cause it's like you have to press the arrow keys and you add the force it, and it takes us to the
Make
next.
it a giant, really tall.
we could do that. Because what's happening is he jumping the well, but the thing is he's getting into the code. Well, or is he? Maybe he's not hitting the collision box. Maybe he's jumping over. Maybe he's not entering the trigger. Let's go here. Here is the collider. I think we have to say, oh, hold on. No, that's the player. I want to go to center. I didn't check his trigger. So actually before, the only reason it was stopping before is it was literally running into it. Our code was not getting executed because we didn't turn on is trigger for our box collider. So we should be able to set the vector to 0 here. Let's see here.
I didn't know there was a. Oh, there it is. Yes, there it is. There it is. That's the main problem with this thing. Yeah. Yeah. So was it a bad idea to reach over the same?
No. Because this is showing a legitimate thing. All right. So why is he still going? I mean, we can add a force in the opposite direction.
Oh boy, did I try that.
And that didn't do anything?
I add the force, but the force even.
Well, because with friction, it's a diminishing return.
Yeah. You can get it to stop. The force you just added makes the gap. I think that's why I think it's the.
So you think it's a rotation thing? Like he's still rotating?
Yeah. Oh.
Still going. All right, let's see what else we have with this rigid body. We want him to stop moving.
So this angular velocity is.
Well, let's see what angular velocity does. The angular velocity vector of the rigid body measured in radians per second. But why is that a thing? Okay, well, let's put it on here first. So we can say angular velocity is equal to quaternion dot identity, which is the zero quaternion. I thought you said it is a quaternion.
So like what it actually is, so we can like look it off.
Well, so if this works, I'm going to turn off the just velocity and just use angular velocity. So that seemed to do it. So now we would be able to make the collision box a little bit smaller and be able to accomplish this. So let's leave it at that for now. There are other ways we can accomplish this, probably by increasing the mass or something like that to, get it to stop. But effectively, what we're seeing here is the game that we have to play against the physics engine. We applied a force to this guy, that force gets it moving, right? And we slowed it down even by setting its velocity to zero. What was still happening is we still had an accumulation of force that hadn't slowed down all the way. We did see it it didn't bump back up to full speed, but it was a diminishing force that had, when we first pushed it, we added a force to it, but it's dealing with the, how much it's interfering with the ground and stuff as it's slowing down, right? It doesn't just go, it's not like traveling in a vacuum. All right. So we would have to offset that to zero in order for it to not keep rolling at some level. So we'd want to get a definition of what this angular velocity is. All right, so I'll go ahead and I'll push this updated code to the cloud. No homework. Remember, we don't have class on Friday. We also don't have class on Monday. So classes after 4 p.m. on Thursday don't meet, and classes before 4 p.m. on Monday don't meet. So the next time I'm going to see you is on Wednesday next week. So maybe keep kind of messing around with this in your free time, but I won't officially give you a homework assignment over Easter. I don't. I'll try to find that answer, but I don't know off the top of my head.
Do you think it has to do with the sphere that upright comes in?
Well, I'm guessing it has to do with the difference between general velocity, which is probably just in a single direction, and angular velocity, which is the velocities from the different angles. And it must be when we add a force on a sphere, maybe. Perhaps this would work initially if we just had it on a cube. Yeah, but since we're adding it on a sphere, angular velocity maybe plays more of a part, but I don't know angular velocity enough to tell you that's for certain what it is. You'd have to experiment with it a little bit.
Well, see you around this one. Have a great
All right, yeah, you take care.
So worked it wrong? You just want to see.
Give me a second, let me get this converting and then I'll.
I was trying to figure out how to make it stop and use the things. So yeah, they did physics.